All right, this chapter is immensely important. It's really the whole idea behind this course. Studying statistics is all about taking sample data and estimating parameters, estimating data from populations, right? You collect what's the average height of the students in your classroom, and then you use that to guess what the average height is of everybody at your school, right? So let's go through an example of this. We are using statistics or a sample value to estimate a parameter or population value. A doctor claims the proportion of girls to be born at 48%. From a study of 212 births, 115 of them were girls. Find a 95% confidence interval about the true proportion of girls born. So we're going to use the fact that we got 115 out of 212 girls, and we're going to guess what the true proportion of girls should be, and we're going to compare it to what the doctor is claiming. So let's then see, do we have significant statistical evidence to argue with the doctor? So we're taking our sample value, 115 out of 212. In fact, let's start there. Let's define some terms. Let's let P be the proportion of girls. Oops. Right, this is what we're trying to estimate. And we'll let P sub S be the proportion of girls that we measured from our sample. So the proportion of girls from our sample were 115 out of 212. Now, if you estimate, you get about 0.54245. And we know that this is a proportion, so it's already a really small number. It's best to go out a few decimal places at least 3, to get an accurate measurement. All right, so P is the proportion of girls that we're trying to guess. P sub S is the proportion from our sample. And let's define maybe an uppercase P as the probability threshold. How certain do we want to be that we have the true proportion of girls? It says that we want to be 95% sure. We want to create a 95% confidence interval. Okay, now let's go through this. Every time you estimate a parameter, you immediately draw a distribution. In this case, we're estimating proportions, so we're going to draw a normal distribution, and the best guess is our sample data. So we're going to center that curve at P sub S, or 0.54245. And we want to move to the right and to the left until we have 95% probability. And we call this the margin of error. So we need to figure out how far we need to move until we collect 95% of our probability. The equation for the margin of error is just a rearrangement of the z-score equation. It's z times standard deviation. And when it comes to estimating proportions, the standard deviation that we use is our sample proportion times 1 minus our sample proportion divided by n. And all of that is inside that square root. So let's go through this. We'll figure out what the z is here in a minute. Let's go ahead and replace all the variables that we know. P sub S is the center of our distribution, 0.54245. And I multiply that by 1 minus P sub S. So 1 minus 0.54245 gives us 0.4, let me zoom in, 0.4575, oops, 55. So reminder, this is all underneath that square root. And I divide that by n, the number of data points that we have. There's 212 babies in our sample. All right, now let's figure out this z value. So to figure out the z value, you just go back to your picture. If we're looking at z-scores, it's centered at 0. And I still want 95% of my area in the middle. So by symmetry, that means I have 2.5% in that tail and I have 2.5% in that tail. So this Z value right there has a total of 97.5 to the left of it. So what's the Z value that has 97.5% of the probability to the left? We need to go to our Z-score table. Right, so this is areas to the left of Z-scores. Now I know the probability. The probability on the left-hand side of the Z value that I'm looking for is 97.5. So I go through all of these values and I look for 97.5. And I see it exactly right there. So which Z value has 97.5% of the area to the left? It's 1.96. So that's the Z value that matches my picture, 1.96. Okay, let's go through this equation in a few different steps. Let's tell ourselves what's inside the radical first. So I'm going to leave that Z-score 1.96 alone. I'm not going to perform the radical, but the consequence of 0.5425 times 0.45755 divided by 212 gives you 0.001171. When you take the square root of that, you get 0.03422. And when you perform this multiplication, you get 0.0671. So this is our margin of error. That's how far we need to move over, to the right and to the left, from the center of our distribution. So if we take our sample proportion and I subtract the margin of error, the center is 0.54245. And if I subtract 0.0671, I get 0.4754. So this point right here is 0.4754. All right, now let's figure out the right-hand interval, or the right-hand point of our interval. If I take the center of the curve and I add this margin of error, 0.54245 plus 0.0671, you get 0.6096. So this point right here is 0.6096. So we just told ourselves that we are 95% sure that the true proportion of girls is somewhere between these 2 points. So we're 95% sure that P, the proportion of girls, is between, what's the lower bound? 47.54%. And the upper bound was 60.96%. Okay, so the doctor claims that the proportion of girls to be 48. Well, we can't really fight him on that because 48 is inside that interval, right? We're 95% sure that the true proportion of girls is somewhere between 47.5% and 60.9%. And they say that it's 48, so we don't have enough evidence to debate them.